Okay, so the chapter 4 is the introduction to the basically the probability, right? I know that you already covered this topic when you take the admin 210, right? And now I think its title is called admin 2000 something. It's now is a this is after semester the Q2S conversion. The numbers, all the numbers have been changed. So I know that it's 2000 something, but anyway, the probability, right? Okay, so the probability is the numerical measure of the likelihood that event will occur, right? So that's the definition of probability. And events is a random experiment is a process that generates the well-defined outcomes. And by specifying all possible outcomes, we identify the sample space for the random experiment, right? So for example, like rolling a dice, your sample space is what? 1, 2, 3, 4, 5, and 6, right? And then coin toss, your sample space is what? The T and tail. I mean, not the tail. What is it?
Head or tail.
Yeah, head and tail. Thank you. Head and tail, right? H and T, right? So thank you. An event is identified as a collection of outcomes, right? Okay, now, so head and tail, and roll dice, right, and etc. Right? So that's a sample space. Okay. Okay. So this is like example of calculating the probability, right? For example, your sample space, the possibility is a 40, and especially this event, it's a 6, right? So 6 divided by 40 is a 0.15, 15% of probability, right? That the completion time is 8 months, right? That probability is about 15%. Okay, so okay, I'll just skip this. Okay, this is an important diagram. Okay, so this is called Venn. Okay, first go. Okay, so this is like a Venn diagram, right? And then another thing that I want you to know is a complement of A. So that's for notation wise. Okay, so if you look at this Venn diagram, right? This is like a sample space. You have a sample space S, and then if this is the event, right? And so the circle, the area of the circle, it's really like representing the event A, right? Probability that event A will take place, right? And then the blue ones, right? That's the complement that representing the complement event A. And then I want you to look at these notations. A, and then they put the C, right? On the subs as a superscript, AC, right? That means complement of event A. Okay, so to basically the equation is that probability that A will take place is equal to 1 minus, right, the probability of the complement, right, AC. Okay. So that's the important formula, right? And then addition there is, okay, first I want you to look at this Venn diagram, right? So this is a sample space, and this is like event A and event B, right? And the intersection is noted as A. Okay, you know what? I have to use the OneNote. Okay, so okay, okay, so basically, let me just draw the Venn diagram because Venn diagram is very important. So you have a sample space, right? and then you have event A and event B, right? So you have event A, event B, and this is the intersections, right? So so to represent the probability of these intersections, right? So I'm gonna use this red, right? This area is like probability that it's A and B, right? By the way, this is notation for the and, right? A and B, and then probability that it's A or B, right? This is or, right? It's basically, you know, this one is everything, right? So that's a probability A or B. Okay, now, okay, so this is a very important formula, additional law. So probability A or B is a probability A plus PB minus P and B, right? The special case arises for the mutually exclusive event. The mutually exclusive means what? If the occurrence of one event precludes the occurrence of the other, if the event have no outcome in common, right? In that case, the Venn diagram is something like this, and that's the additional law for the mutually exclusive event, right? So, for example, so I mean this is the event, right? Assuming that there is an intersection between A and B. If, however, if A and event A, right, and event B are the mutually exclusive, right? Then your Venn diagram is going to look like this. Okay, by the way, first of all, but this is what PA plus PB minus PA and B, right? And when the events are A and B are mutually exclusive, there's nothing in common, right? So this is event A and event B. And then, so this is a formula for this PAB is PA plus PB, right? So since there's no the common area, right? So that's the formula, right? For the mutually exclusive event. Okay, now, so that's like a basic formula, right? By the way, this is probably mostly the review, right? Okay, and let's see. Okay, so the next one is the conditional probability, right? Okay. By the way, I'm recording my lecture. Okay. This is like an interesting example. Before we move to conditional probability, right? Let's just look at this example, right? So that this is an example of mutually exclusive events, right? So, I mean, for example, tossing a coin, right? The probability of having tail and head, of course, that's a mutually exclusive event, right? Because you cannot have both at the same time, right? So it has to be either tail or it has to be either what? The head, right? T or H. And another interesting example of mutually exclusive events is, let's say, okay, for example, let's take a look at this example. So you're rolling a dice, right? So rolling a number divisible by 2 or rolling a number divisible by 3. So is that two events are mutually exclusive? No, because, okay. For example, right? So we define, so this is like, this is an example, right? and like tossing a coin, like let's say event A is like having a probability of having what? Let's say head, and event B is like, let's say the tail, right? So this event A and event B is of course the mutually exclusive. So that means PA B is equal to 0, right? Because you cannot have H and T simultaneously, right? So when you toss a coin, you either have H or the T. So these events are mutually exclusive. And another example is what? Let's say rolling a die, right? So let's say rolling a number divisible by 2, right? So that's the event A. And event B is rolling a number, right? And divisible by, let's say, 3. So this is we call this event as a B, right? So we have event A and event B. Here's my question: is this 0 or not?
No.
No, right? Because a good example is, let's say you're rolling a die, and then let's say you get 6, right? You could roll a 6, right? So number 6. And you know that this is divisible by 2, but at the same time, it's divisible by 3. So it's not equal to 0. So event A, event B, are not, okay, are not mutually exclusive. Okay? And another mutually exclusive, it's okay, and I think this is another interesting example. Let's say rolling a dice and rolling a non-prime number. Let's see, the event A, we call it a rolling a non-prime number. Right? By the way, what is a prime number? 1, 2, 3, and then 5. I think those are the prime numbers, right? And okay, so non-prime number, right? So these are the prime number, right? So the non-prime number, and I'll call it NP. Non-prime number is what? 4 and 6, right? So that's a non-prime number. And then rolling an odd, so event B is, let's say, rolling a odd number, right? Rolling an odd number. So the odd number is what? We have 1, 3, 5, right? And rolling a non-prime number, so non-prime number is we have a 4 and 6. So here's my question. Is that event A and event B, is this events are mutually exclusive or not? Anyone? Anyone?
Not mutually exclusive?
Pardon?
Not mutually exclusive?
Yes, it's not. Okay, so that means it's not the mutually exclusive.
I don't understand it. Can you explain it?
Because, okay, so when you're rolling a die, right?
You can't get A and B at the same time.
You cannot get A and B at the same time.
Oh, okay.
Because the event A is you either get 4 or 6, right? And event B is you either get 1, 3, or 5. And you know that A and B can take place at simultaneously, right? Because there's, so if you use the Venn diagram, right, for A and B. So let's just draw the Venn diagram, for this case. So we have A, right, which is what? I mean, for the sample space, we know that 1, 2, 3, 4, 5, 6, right? That's a sample space. But let's say this is event A. And then for event A, you have a 4 and 6, right? And this one, for event B, right? We have 1, 3, and 5. 1, 3, and 5. You see that there is no the common, right? Between event A and B, there is no common area. So that's why event A and event B are mutually exclusive. So for the notation, right? Oh, sorry. No, I made a mistake. So it's since it, okay. Hold on. I mean, what I'm saying. Okay, so this is what? This is a mutually exclusive event, sorry. You know. Yeah, right. What I'm saying. I was thinking something else. I'm sorry. So, and as you can see, there's no common, right? No common area. So that means what? This is a mutually exclusive. Sorry.
So if they both had a number in common, it would be.
So for example, okay, so let's look at this example number 2. This is not mutually exclusive, right? Not, right? So why? Because let's just draw, so rolling a number divided by 2, right? So let's just list all the possibilities. So rolling out, so is that 1 is not divisible by 4, I mean 2, right? And then 2, yes, is divisible by 2. So we have 2. So let's say event A. So we have a 2, right? And then 3, no, it's not divisible by 2. What about 4? Yes, it's a divisible by 2. So 2, 4. And then 5, no, it's not divisible by 2. What about 6? Yes, the 6 is divisible by 2, right? So basically event A is 2, 4, and 6, right? Now let's look at the event B. Is that the rolling a number divisible by 3, right? Is that 1 is not divisible by 3? 2? No. 3? Yes. So 3 is divisible by 3. And 4? No. 5? No. 6? Yes. Because 6 is divisible by 3. So 3 and 6, right? So that's the, so this is the A, 2, 4, 6. And this is the B, right? So if you use the Venn diagram, I hope there is enough space for this. Yeah, I think I have enough space on the right side. So right now I'm talking about the case number 2. Right? So let's just draw the Venn diagram. And event A is 2, 4, 6, right?
Yep.
2, 4, and 6. And event B is what? 3 and 6, right? So you see that there's a common area, right? You see that? And that's why these A and B are not mutually exclusive. So compare this with this, right? So in here we have common area, right? So this is not mutually exclusive. And this is what? Mutually exclusive. Okay? So any question? Okay. You know what? I'm going to stop my lecture here, right? I'm going to talk about conditional probability on Thursday. Okay, first let me start recording my lecture.